Hello, AP Stats students. I apologize I was not there yesterday and today, but I thought I would give you the answers for yesterday's lesson in case there was some confusion because you got a pop quiz and you didn't know what those correct answers were. But I'm going to hopefully give that to you today and clear up some of the what the big takeaways were for this particular lesson. So this is lesson day 7 on our schedule, and we are looking again at binomial distributions. So let's read the question together. It's time for a pop quiz. We hope you're ready. It consists of 5 multiple choice. That's important too, I think. And each question has 5 answer choices labeled A through E. Or actually, this should say D because we only have 4 choices up there. Now for the bad news. You do not get to see the questions. You just have to guess the answer for each one. So if you did do your answers, and you can check them next to mine, you can see how many you got correct. I gave myself a 3. I'm sure you guys did much better. And maybe you used James' little eeny, meeny, miny, mo to figure out which answer was which, but you didn't even know the question, so how could you know the answer? Anyway, so I hope you had a little bit of fun with that. So the question number 2 asks us, let x, that's our value, be the number of guesses correct. Is this a binomial setting? So let's go ahead and double check that here. So binomial means we have a scenario where there's one or another option only. We only have 2 different variations to look at. And what we are looking at for each question is if we got it correct or not correct. So that's how we make it a binomial distribution. We have correct or not correct. So that makes it binomial. But we got to keep going to make sure it's an actual true setting. We have to go through all of our criteria. So this one is check mark yes. So for independent, are these answers independent of each other? They are, so we can go ahead and check that off. For N, we need to know how many. We need to know a finite number of questions that we're looking at, and we know it's 5 different questions, so we put check mark there. And does each question have the same probability? That S stands for same. Remember, you have A, B, C, or D. You have a 1 out of 4 chance of getting the correct answer. So yes, each of these questions have the same probability outcome. Okay, so number 3 says calculate the probability of getting exactly 2 correct answers and show your work. So probability of where our value of x is equal to 2, again, that's our number of correct. So I'm going to use that formula that we looked at a couple days ago, where the first part of it is the different combinations of actually getting 2 out of 5 correct questions. So it'd be 5, of course, is your total number. 2 is how many you got correct, and that C again stands for combinations. Times, remember this is our probability. This is the 2 stands for how many we got correct. And then we have 1 minus our probability. And then we have 5, which is our total number of questions, minus 2, which is how many we got correct. So that gives us a number of 0.264 or approximately 26%. All right, so for the table for question number 4, fill in the table below showing the probability of getting exactly x correct. So probability of x equals 0, x equals 1, x equals 2, x equals 3, x equals 4, and x equals 5. So notice that this answer is the same as this right here. So you would do the same formula for each one of your probabilities. And remember, all those probabilities need to total up to 1. So that's how you can kind of double check your work. All right. Once you have that information, it asks you to find and interpret the mean of the distribution. Show your work. So remember, our mean of this distribution is our expected value. So we're going to take the sum of our independent x values. There's our independent x value. That's an xi, xi, xi. And our individual probabilities right here underneath them. And we're going to sum them or add them all together. And we should get a total of 1.25. That is our mean, meaning even if we interpret this after many quizzes were taken, the average correct answers we can expect out of 5 is 1.25. Now, what we can notice is if we go back and you see this little highlight of this part in red here, my mean actually ends up being our number of questions times the probability. So this answer, 1.25, is just 5 times 0.25. So without having to do this whole calculation for the expected value, if you know the number of trials or number of questions in this case and the probability, you can find the mean without calculating this whole expected value on its own by summing up all of the total probabilities. So that's nice. So that's for a binomial distribution. We can do that. All right, the next one is the standard deviation. And again, I didn't want to write out the formula. I just wrote out, have the room. But you'd use your standard deviation formula, or you could use the calculator. You could put these two in a table and use your second vars, or excuse me, one vars, and use this as your first list. This is your frequency, is your probability, and you could find your standard deviation. And that standard deviation came out to 0.968, which is the typical number of correct answer that varies 1.968 from the mean. So we also notice that if I was to take that n value, whatever our finite amount of numbers are, times the probability, and then times 1 minus the probability, that was our 0.25, and take the square root, you can find the standard deviation without doing all that other work. So you have two new formulas to add to your notes for binomial distributions. And again, we can't use these formulas until we have checked off all of our 4 for the settings. So we know it's a binomial setting, and then we know we can use this formula and this formula if we know how many trials or how many questions and the probability. So we don't have to do all these tables. We actually have a kind of a shortcut now. All right, last couple of questions. What is the probability of getting at most 3 correct? So at most 3 is going to be the 3 is where the value of x is less than or equal to 3. So our at most 3 means that we're looking at 0, 1, 2, and 3. So we're going to add those probabilities up and we get a 0.985, which is about 99%. That's a lot of it. Then, so that's what you can do it here. But we actually have a nice shortcut in our calculators. And I will show you this when I get back, but I wanted to have you have this note. It is called the binomial CDF. And again, if we know that n value, the number of trials, the probability, and for this one, at most 3, that's our value. So our 3 would go in here. You can calculate that number, that probability. And then if you have the probability of getting 3 or more, well, the way the CDF works is that we are looking at only one side. So if we have 3 or more, we have to think about it as 2 or less, because what we are doing is we're going to subtract 1 from our CDF in order to find the answer. So right in here, our x value actually becomes 2 because we want the rest of them. We want the ones that go from 2 or little to calculate that 3 or more. So once we know what that value is for x, we can put it in the binomial CDF. And once we get the number, we will subtract 1, and that will give us our 0.104. Again, I think it is on your cheat sheet for the calculators, but we will be going over that when I get back into class. All right, I hope that was helpful. The check your understanding I plan to do together as a class when we get back, just so that I can make sure we're all understanding where we are at. I hope everyone's feeling well and I didn't pass on my sickness, and hopefully I'll see you guys on Thursday.